Here's something that should make you deeply uncomfortable. Every time the United States announces a new round of sanctions on China, there's a quiet celebration happening in Beijing. Not public, not loud, but very real. And if you think that sounds backwards, you're exactly where most Western policymakers have been for the last decade, completely missing what's actually happening. Let me be clear about something up front. I've spent time talking to officials in both Washington and Beijing. I've sat in rooms with trade economists who advise Fortune 500 companies. And here's what nobody wants to say out loud. American sanctions have become China's most effective industrial policy tool. We're not just failing to slow them down. We're actively handing them the blueprint for technological independence. The question isn't whether sanctions work anymore. It's why we keep using a weapon that's been captured and turned against us. Now, I'm going to show you 3 systems that explain how this happened. 3 interlocking forces that transformed what should have been America's leverage into China's advantage. And by the end of this, you're going to see the last 2 decades of US-China relations in a completely different light. System 1, the roadmap gift. Here's what most people think sanctions do. They cut off access, cripple industries, force behavioral change. That's the theory. But here's what sanctions actually do when applied to a developmental authoritarian state with deep pockets. They provide perfect clarity about exactly which technologies matter most. Think about it this way. When the US sanctioned Huawei in 2019, blocking access to advanced semiconductors, what did that signal to every Chinese policymaker? It told them with absolute precision that semiconductors are the choke point, the critical vulnerability, the thing worth spending unlimited resources to fix. I spoke with a Shenzhen-based chip engineer last year who put it perfectly. He said, before the sanctions, we had 50 priorities. After the sanctions, we had 1. That's not weakness. That's focus. And Beijing responded exactly how you'd expect a centrally planned economy to respond when given a crystal clear strategic target. They launched the big fund, officially the National Integrated Circuit Industry Investment Fund. The first phase, 138.7 billion yuan. That's not a rounded number. That's 138.7 billion yuan, which is roughly $21.9 billion poured directly into semiconductor development. But here's the part that should terrify anyone paying attention. The second phase was 204 billion yuan. They didn't scale back, they doubled down. And these aren't market-driven investments that need to show quarterly returns. This is patient capital with a 15-year horizon and unlimited government backing. Do you see what happened here? The sanction didn't create a barrier. It created a mission statement. Let me show you the numbers that matter. In 2015, before the sanctions era really began, China imported $260 billion worth of semiconductors annually. That's billion with a B, making chips their single largest import category, bigger than oil. By 2020, that number had grown to $380 billion because their tech sector was booming and still totally dependent on foreign chips. Now here's where it gets interesting. Chinese domestic chip production in 2015 met about 15% of domestic demand. Pathetic, right? That's what American strategists saw, total dependence, maximum leverage. But that 15% number is exactly why sanctions backfired, because when you're at 15% self-sufficiency, you have enormous room to grow. You have a massive domestic market already consuming the product. You have demand certainty. All you lack is the focus and political will to build capacity. And guess what sanctions provide? Exactly that focus, exactly that political will. A senior economist who advises on US-China trade told me something off the record that stuck with me. He said, we basically ran the greatest industrial policy workshop in history. We taught them which sectors to prioritize, how much to spend, and gave them the nationalistic political cover to subsidize the hell out of it. Stay with me because what comes next is even more sophisticated. The roadmap was just the first gift. The second system is about what happens when you combine that roadmap with something China has in abundance and the West has completely forgotten how to use: the willingness to fail expensively. So here's the second force at work, and this one operates completely differently than anything possible in a market-driven democracy. System 2, the failure subsidy machine. Western analysts love to mock Chinese chip companies for being years behind TSMC or Samsung. They'll point out that SMIC, China's flagship semiconductor manufacturer, is still struggling to reliably produce 7nm chips, while TSMC is already mass-producing 3nm technology. And they're right about the gap. But here's what they're completely wrong about, thinking that gap matters in the way they assume it does. Let me explain what I mean. In a normal market economy, if you're 2 generations behind the technological frontier and burning billions in subsidies to produce inferior products, you die. Your investors pull out, your talent leaves, the company collapses. That's creative destruction. That's capitalism working as intended. But what happens when failure isn't punished? What happens when the state absorbs infinite losses because the goal isn't quarterly profits, it's strategic independence? Here's the uncomfortable truth. China isn't trying to beat TSMC at making the world's best chips. They're trying to make good enough chips that can't be sanctioned. And good enough keeps getting better when you can afford to fail for a decade straight. I talked to factory workers in Hefei where they're building out new fabrication plants. These guys told me about production lines that run at 30% yields, meaning 70% of the chips coming off the line are defective. In any Western facility, that's catastrophic. That's shut down the plant territory. But these lines keep running, 3 shifts, 7 days a week, because each failure teaches something, each defect gets analyzed. Each engineer gets trained. This is something Americans used to understand, by the way. How do you think we got good at building aircraft carriers? We built a lot of bad ones first. We just did it 80 years ago when people's memories were shorter and quarterly earnings reports didn't exist. Now let me show you what this actually means in practice. Between 2014 and 23, the Chinese government has provided an estimated $150 billion in direct subsidies to the semiconductor industry. Not loans, not tax incentives, direct cash injections. And here's the specific number that matters. According to industry analysis, roughly $50 billion of that has effectively been burned, spent on facilities that underperform, technologies that didn't pan out, companies that failed. In Washington, that $50 billion failure would be a scandal. Congressional hearings, political careers ended. In Beijing, it's the cost of education, it's buying knowledge. And here's the thing about knowledge, once you have it, the next $50 billion gets much better results. By 2022, Chinese domestic chip production had reached approximately 28% self-sufficiency. Remember, they were at 15% in 2015. That's not dramatic, that's not a miracle, but it's real, measurable progress in the exact direction sanctions were supposed to prevent. And here's where it connects to something even bigger. Every percentage point of increased self-sufficiency doesn't just reduce dependence, it reduces the future effectiveness of sanctions. It's a declining returns curve for American leverage. The weapon degrades with each use. Let me give you a concrete example of how this plays out. In 2020, the US put Huawei on the entity list, cutting off access to chips made with American technology. Devastating blow, right? Huawei's smartphone business collapsed. Their global market share dropped from 20% to basically nothing in premium phones. But here's what most people missed. Huawei didn't disappear. They shifted. They took those thousands of engineers who'd been designing smartphone chips and moved them to other projects, automotive chips, Internet of Things processors, AI accelerators for domestic cloud computing, all the areas where cutting-edge 3-nanometer performance doesn't matter as much, but volume and reliability do. A tech analyst in Shenzhen told me something that crystallized this perfectly. You didn't kill Huawei, you freed them from having to compete with Apple. Now they can focus on markets where being good enough is good enough and where their government connections actually matter more than brand prestige. If you're finding this valuable, hit that subscribe button because the third system is the one that actually keeps me up at night. It's about what happens when you combine that technological roadmap with failure tolerance and add one more ingredient. System 3, the nationalism amplifier. Here's the part that should genuinely worry anyone thinking about long-term strategic competition. Sanctions don't just create technical focus and financial commitment, they create emotional fuel. They transform industrial policy from a bureaucratic priority into a patriotic mission. And that changes everything about execution speed and public tolerance for sacrifice. Let me ask you this. How do you convince an entire generation of talented engineers to work on semiconductor manufacturing instead of chasing higher-paying jobs at internet companies? How do you get brilliant physics PhDs to spend years in fabrication plants instead of comfortable research positions? In a normal market, you can't. The pay gap is too big. The prestige differential is too wide. But what happens when working on chips stops being just a job and becomes national service? When it becomes about proving that China can't be pushed around, When state media runs stories about young engineers as patriots fighting technological containment, I'll tell you exactly what happens. You get talent flows that don't make economic sense but make perfect nationalistic sense. Here's a specific data point. Between 2018 and 2022, enrollment in semiconductor-related programs at Chinese universities increased by 68%. That's not gradual growth, that's a boom. And it coincides almost perfectly with the escalation of US tech sanctions. Students are literally choosing career paths based on where they perceive the national struggle is happening. A university professor in Beijing told me something that stuck with me. He said, 20 years ago, our brightest students wanted to work for American tech companies. 10 years ago, they wanted to work for Alibaba and Tencent. Now, they want to work on whatever America says we can't have. Do you see the paradox here? The weapon that was supposed to create weakness became the source of resolve. And this isn't just about warm feelings and propaganda. Nationalism converts into measurable policy tolerance. It means the Chinese public accepts, even demands, massive government spending on strategic industries. It means local governments compete to offer subsidies and land deals to chip manufacturers. It means engineers accept lower salaries than they'd get elsewhere because there's social prestige attached. Think about what that enables. The US government has tried to boost domestic chip production through the CHIPS Act, $52 billion in subsidies. That sounds like a lot until you realize China is spending 3 to 4 times that amount and facing virtually zero political opposition, no debates about industrial policy versus free markets, no complaints about picking winners and losers, just unified strategic commitment. Here's the uncomfortable truth that most Western commentators won't say. Authoritarian systems have a distinct advantage when it comes to long-term industrial mobilization, especially when you gift them a clear external enemy to mobilize against. Let me show you how this plays out in practice. In 2022, SMIC announced they'd somehow produced a 7-nanometer chip despite being cut off from ASML's extreme ultraviolet lithography machines, the equipment everyone said was absolutely essential for that level of manufacturing. Western analysts were shocked. How did they do it? The answer involves a combination of older deep ultraviolet technology used in creative ways, tolerance for lower yields, and probably some technical breakthroughs that came from having thousands of engineers working on nothing but this exact problem for years. Could TSMC do it better? Absolutely. But TSMC was never cut off from ASML machines, so they never had to develop the workaround. Necessity didn't just mother invention, sanctions mothered innovation in the specific areas we wanted to deny. And here's what makes this really fascinating. Every technical workaround China develops becomes permanent knowledge. You can't unsanction that knowledge. Even if tomorrow the US lifted every restriction, China now has expertise in alternative manufacturing methods. They have engineers trained in backup approaches. They have institutional knowledge about operating under constraints. A former US trade official told me off the record, we're teaching them self-sufficiency. And you can't unteach that. Even if relations improve, they'll never be as dependent again. This connects to something crucial about how power actually shifts in the 21st century, and I need to pull all 3 of these systems together to show you what's really happening. Let me pull this together because when you see all 3 systems operating simultaneously, you understand why sanctions have become counterproductive. The Sanctions Paradox Framework System 1 gave China the roadmap, perfect clarity about which technologies represent strategic choke points. System 2 gave them the mechanism, state capacity to subsidize failure until it becomes success. System 3 gave them the fuel, nationalist legitimacy to maintain public support for enormous costs and sacrifices. Together, these 3 forces create what I call the sanctions paradox. The more aggressively America uses technological restrictions, the faster China builds the exact capabilities those restrictions were meant to deny. We're not slowing their development. We're focusing it. We're funding it through nationalist mobilization. We're teaching them resilience. Now, here's my question for you. If this framework is accurate, and I believe the evidence overwhelmingly shows it is, what does that mean for the next decade? Let me give you my honest assessment, and this is where I move from analysis to opinion. I think we're watching one of the great strategic miscalculations of the early 21st century. Not because technological competition with China is wrong, it's absolutely necessary, but because we chose a tool that worked brilliantly against the Soviet Union and assumed it would work the same way against a completely different type of adversary. The Soviet Union was technologically isolated by choice, economically sclerotic, and declining in national confidence. China is the opposite on every dimension. They're integrated into global supply chains, economically dynamic and riding a wave of nationalist confidence. Sanctions that would have deepened Soviet weakness instead catalyzed Chinese adaptation. Here's my doubt though. The thing that keeps me from complete certainty, can China actually close the gap at the technological frontier? Making 7-nanometer chips is impressive, but making 2-nanometer chips at scale, that's exponentially harder. Physics doesn't care about political will or subsidies. At some point, you hit barriers that money and engineers can't overcome without access to specific equipment and expertise. Maybe, and this is the optimistic scenario for the West, China hits a hard ceiling around 5-nanometer technology. Maybe ASML's EUV lithography really is unreplicable without decades more development. Maybe we've bought ourselves a permanent advantage in cutting-edge chips, even if we've lost the mid-tier market. But here's my prediction, and I want you to remember this. By 2030, China will achieve approximately 50% semiconductor self-sufficiency, not 100%. They won't match TSMC at the absolute frontier. But 50% means sanctions lose most of their coercive power. It means they can manufacture advanced weapons systems, AI infrastructure, and telecommunications equipment without depending on imports. And that's the geopolitical game, not winning chip-making Olympics. The second prediction, we're going to see this exact same pattern repeat in other technologies. The US will identify a critical choke point. Maybe it's AI training chips, maybe it's advanced batteries, maybe it's quantum computing components. We'll impose restrictions. China will interpret those restrictions as a roadmap, subsidize domestic alternatives, and mobilize nationalist support. And 5 to 7 years later, we'll be having the same conversation about whether sanctions backfired. The third scenario, the one I hope for but don't expect, we figure out that technology competition requires building our own capacities faster than we can restrict theirs. That means industrial policy, which Americans are historically terrible at. That means patient capital, which our quarterly earnings system resists. That means cultivating engineering talent, which requires fixing our education system. All hard, all possible, all necessary. Here's what I actually think happens. We continue using sanctions because they're politically easy and strategically familiar, even as their effectiveness continues declining. China continues converting each new restriction into focused industrial policy. The gap narrows, not everywhere, not at the absolute cutting edge, but in enough places that our leverage gradually evaporates. And one day, probably around 2035, we'll look back and realize that the era of American technological dominance ended not because China out-innovated us, but because we spent 15 years teaching them exactly how to reduce their dependence on our innovation. So here's my question for you, and I want you to answer in the comments. Is there a way to compete with China technologically without using sanctions that accelerate their independence? What would that strategy actually look like? If this analysis gave you a different perspective, subscribe because I'm going to keep following exactly where this leads. The next evolution is already happening, and most people aren't paying attention yet.